Hey, in this tutorial we're looking at section 14.4, which is on confidence intervals. Hey, so we found in 14.3 that p hat, which is our population proportion, okay, will or may be different for different samples. Okay, this means it can be hard to make predictions about the population. Okay, confidence intervals. So these tell us a range of values that a population parameter may have. Okay. To get a certain percentage of confidence. So usually, okay, we'll have 95% or 99% confidence intervals. Okay, so we say, well, our population proportion is going to be between, say, 20% and 30%. Okay, of Australians will own a dog, for example. Okay, so that's giving us our confidence interval. When we actually found our population parameter, it might have been, say, 25%. Okay, but we're giving ourselves that margin of error, or our confidence interval, okay, saying that it's from 20 to 30% instead. Okay, the higher the confidence percentage, okay, the bigger the range of values for the population parameter. So if we said the 95% confidence interval for our example of the dog ownership, okay, gave us a range of 20 to 30, okay, 99% confidence interval is probably going to be something like 10 to 40%, something like that. Okay, it's going to be quite a fair bit higher, okay, and bigger range. Okay, so we find our confidence interval, okay, by here. Okay, so it looks horrible because we're p hat minus z times the square root of p hat outside of 1 minus p hat on n, okay, to p hat plus z outside of the square root of p hat outside of 1 minus p hat on n. Okay, so remember p hat is our sample proportion, z it's our z value for the confidence interval. Okay, so we actually have to do some work with our z values, okay, like we did with our. So this is like our standard normal value. Okay, we're talking about. Okay, and then n is our sample size. Okay, so this will give us our lower end of our range. This will give us our upper end of our range. Okay, so for the 95% confidence interval, okay, we actually get a z value of 1.96 that goes in there. For our 99% confidence interval, we get z equals 2.58. So these ones are probably the ones that we're most likely to use. Okay, but okay, if we need to find an appropriate z value, use your calculator, set on center with the appropriate probability, i.e. 0.95 or 0.99, etc. Okay, so that's what we need to do for that, to find them. Okay, so our margin of error, m, okay, is simply this part here. Okay, we call this our margin of error. Okay, because it's going to be the same for both of them. Okay, so again, with our example of our 25% pet ownership and the same 95% confidence interval, we're going to be from 20 to 30. Well, then our margin of error would be saying is 5%, because this part would equal our 5%. This would be our 25%. This would be minus 5% or plus 5%. Okay. So we need to have a look at some worked examples on this. Okay, there are 20 people in your class and 25% are planning on buying their lunch. So we can say, well, n equals 20. Our population proportion is 0.25. Okay, estimate the proportion of the school population that will purchase their lunch today. Okay, and find a 95% confidence interval for your estimate. Okay, so our 95% confidence interval, okay, is when z equals 1.96. Okay, so we know that our n is 20, our p hat is 0.25, our z equals 1.96. So what we need then is our z times our square root of p hat outside of 1 minus p hat over n. Okay, so that means that we have our 1.96 times our square root of our 0.25 side of 1 minus 0.25 over n, which is 20. Okay, when we do that, we find that we get 0.1898. Okay, and again, that was our margin of error, so we would say we had a margin of error of 18.98%. Okay, so now we set up our confidence interval. Okay, because we've got to do our p-value, which is 0.25 minus this value, 0.1898, and our p hat value, 0.25 plus 0.1898. Okay, which means, okay, we're going to be between 0.0602 and 4.4398. Okay, so that means that we're going to be saying that we can be 95% confident that between 6% and 44% of people will buy their lunch today. Okay, that's the idea with that one. So we'll have a look at work example 9 now. So poll samples 102 people. Okay, so that's going to be our N, 102. Right, and finds that 18 of them like drinking coconut milk. So our P hat, okay, is going to be our 18 people out of our 102, okay, which is going to be 0.18 is fine to 2 decimal places. Okay, estimate the proportion of the population that likes drinking coconut milk. Okay, find a 99% confidence interval for your estimate, correct to 1 decimal place. Okay, so basically we're saying that our estimate of the proportion of the population is going to be our P hat, our 0.18. Okay, so for our 99% confidence interval, Z equals 2.58. So that means that we're going to get our 2.58 times the square root of our P hat, which is our 0.18, times our 1 minus 0.18, over our N, which is 102. Okay, which means we're going to get 2.58 times the square root of our 0.18 times our 0.82 over 102. So when we do that, we get 0.098. Okay, so that means then, okay, that we now have our margin of error. We've got our population proportion. Okay, so we can put those in. So we get our confidence interval then is going to be 0.18 minus 0.098 to 0.18 plus 0.098. Okay, which means we're going to get 0.082 to 0.278. Okay, so we can say that our we can be 99% confident that between 8.2% and 27.8% of the population like coconut milk. Okay, and that's all there is to that one. So we've got one last worked example. Okay, and it is in fact the very last worked example in the entire textbook. So the last worked example to look at for the entire year. Okay, which is worked example 10. Okay, grow well are 95% sure that 30% to 40% of shoppers prefer their mulch. What size sample was needed for this level of confidence? Okay, well, our P hat, okay, has to be in between our 30 and our 40, and it's got to be right in the middle. So I can say, well, P hat equals 35% or 0.35. Okay. For our 95% confidence interval, well, our Z equals 1.96. Okay. So our lower score was our 0.3, okay, and that's got to equal our 0.35 minus our Z, which is 1.96, times our square root of our P hat, which is 0.35. So to 1 minus 0.35 over N. Okay, so when we start to solve this, okay, well, we find that when we do this, we can say, well, it's going to give us an N value. Okay, and it's just a little bit of calculator work here. Okay, really to find our n, and it's 349.586. Okay, so we need 350 people. Okay, now we could have also done our equation for our 0.4, and it would have been our 0.4, and this would have been plus instead. Okay, so we could have done 0.4 equals 0.35 plus our 1.96 times the square root of 0.35, 1 minus 0.35 over n. Okay, and we still would have found the same value for n. Okay, so that is in fact all there is for this tutorial, and in fact it is the last tutorial for our content on maths methods. So hopefully you got enough to get through these questions. Okay, and good luck with your exams at the end of the year.